This is MathType for Microsoft Word. You can download MathType at the Design Science website, and you can download it for Windows or Macintosh. You can select a free 30-day trial, and after 30 days you pretty much have a working version of MathType without some of the special features. So once you've installed it, there'll be MathType on your toolbar that you can select to type in equations into your document. Some of the shortcut keys you can use, Control H for a superscript, Control L for a subscript, Control F for fraction, and Control G for Greek symbols. Also, you can use copy and pasting often when you're developing your document, and I'll show you some examples of that. So for an example, let's type Einstein's energy-momentum relation. So I'll go to MathType. I'm going to select a display equation, and the box pops up. You can just type in your equation. So Control H for superscript, the momentum squared times the speed of light squared plus the mass squared times the speed of light to the fourth power. Now I can use Control H for superscript, or I can go here. If you don't want to do this, you can type using this symbol here. We can also move our expressions around. I'll put this over to the left. Next, we want to solve the energy-momentum relation for the energy E. So I'm going to copy and paste and type on it. So I'm going to solve this for E. I just have to take the square root of both sides. I'll take the square root of the left, and that's moves the E squared here. Technically, there's a plus or minus that we have to put in. You can select a plus or minus. The minus sign to interpret in terms of antiparticles, usually we take the plus sign. So we'll write the energy-momentum relation for the special case of a massive particle at rest with zero momentum. So I'm going to paste this expression. I'm going to take the positive square root. For zero momentum, I simply take out this term, p squared c squared. And then we're just left with mc squared. So that's the energy of a massive particle at rest. Next, we want to look at the energy-momentum relation for the special case of a massless particle with zero mass. For example, for photons and neutrinos, we often use this expression. Once again, I'm going to take the positive square root. And now we have a massless particle, so this term is 0. And we simply have E is equal to pc. So the momentum of a massless particle is given by its energy divided by the speed of light. Next, we want to type the relativistic time dilation factor, gamma. So go to MathType. I'm going to select a display equation. I can use Control G for a Greek symbol. So Control G, G. Try that again. If you don't want to hit Control G, you can also go and select a Greek symbol up here. Now to make a fraction, I use Control F. 1 over 1 minus Control F, b squared over c squared. We need a square root on the bottom. Now, if you don't want to hit Control F for fractions, you can also go to the fraction symbol and select different styles of fractions. So that's the relativistic time dilation factor gamma. Next, we want to find what speed corresponds to gamma equal to 2. So I'm using MathType not only to write expressions, but also to do algebra. It's not as fast as doing algebra on paper. So we select gamma equal to 2. Next we want to square both sides of this expression. So if I square both sides, that becomes a 4, and this square root goes away. So I simply write what's inside of the square root, and I'm copy and paste it. Next we can interchange the numerator and denominator, or cross multiply. So I'm using a copy and paste feature. So I'll write 1 minus v squared over c squared here. And a 4 down below. Copy that. Okay, that's one MathType expression. So I'm creating another MathType expression below it. And what I want to do is solve for v. So I subtract 1 from both sides and I multiply by minus 1. And we have v squared over c squared is equal to 1 minus a fourth, or 3/4. Now I can multiply by c squared and take the square root of both sides. Control F. Which is 0.866 times the speed of light. It's usually better to write velocities in terms of some decimal times the speed of light. That gives you a better idea of the velocity. If you were to put in 3 times 10 to the 8 meters per second for c here, you wouldn't have a good idea of what fraction of the speed of light that was.